Hey guys, welcome to the next data science tutorial, and today we will discuss about Pandas. So Pandas stands for Python Data Analysis Library, which supports reading and writing Excel spreadsheets, CSVs, and a whole lot of manipulation. Pandas is one of the best libraries of Python, which is used to deal with datasets from Excel files and CSV files, that is for machine learning and data science. Now let's see how we can use pandas in our program. So to use pandas, we will have to import it first. So import pandas as pd. So here I have imported this library, and now I'll show you how you can read a CSV file in your program. So this is the CSV file that I have, and it is saved on the same place where my this Jupyter file is saved. So now I'll show you how we can read the CSV file. So for that we will use df equals to pd dot read underscore CSV, and in bracket I'll use my file name. It's nycweather dot CSV, and if you write df, and here you can see this is the data which is saved in my this file. So here you can see it's a big data. So in this way you can read the CSV file in your program. Now here you can see there are many columns est, where you can see the dates and temperature, dew points, and so on. Now let's say you want to find out the maximum value of the temperature. So for that you will write df in bracket temperature dot max and bracket close, and here you can see 50 is the maximum value which is there in temperature column. So in this way you can find out the maximum values of any column. Now let's say you want the values of only those est column where the event values are rain. So for that I'll write df in bracket est and then df, and here in bracket I'll write events equals to rain. So here you can see est is the column of the dates and df is the variable in which this whole data is saved. So from this whole data I want the values of est, and what values I want, where the values of events are rain from the whole data. And here you can see these are the dates where the values of events are rain. And the interesting thing is that it is giving me with the indexing. So at 8th index, this is the value where the value of events is rain, and so on. So we can check that here it is on 8th index, this is the value, and yes, in events the value is rain here. So in the same way you can check these values as well. So in this way you can take out the values from your data. So this is how you can play actually with your data. Now here you can see there are so many nan values in event columns, and some are in wind speed column, and so on. So now let's say you want to replace these NN values which you can see here, let's say with 0. So for that I'll use df dot fill na, and in bracket I want to replace it with 0 and comma in place true. So the reason of using this in place true here is that I want to make these changes in my existing data. So that's why I'm using it here. So if I'll not use it in place true here, then it will definitely show me the data which is replaced with 0, but it will not make the changes in my existing data. So this is the only reason why I am using this in place true. So in this way I can do that, and if you will print, let's say df, then here you can see in the output all the values which are nan are now 0, and in wind speed also you can see 0 0. Let's say I have this data, weather data, and here you can see this is a dictionary where keys and values are available. So here you can see the key value pair: days, temperature, wind speed, events. These are the keys and these are the values of these keys. So this is the dictionary, and now I'll create a data frame. So for that I'll use tf equals to pd dot data frame, and in bracket I'll pass this data underscore data, and if you'll print df, then this is the data that I was talking about, and this is the same data that you can see here. So with the help of this data frame, I have created this data in a proper format. Like you can see the number of rows and columns here, and also it is showing me the indexing. So in this way you can use this data frame, and if you want to check the shape of your data, like number of rows and columns, then in this way you can use shape method, and there is a method called head which will give you the top 5 rows of your data. So you can see 0 to 4 it is showing here, so it is giving you the top 5 rows. And if you want to print the bottom 5 rows, then you can use tail method, and here we go. So this time you are getting bottom 5 rows of your data. Now we can also do slicing here. Let's say you want to print which starts from 1 to, let's say, 3, means it will start from 1 and print till 2. So here you can see first and second row of your data. So in this way you can also do slicing, and let's say you want to print all the columns which are there in your data, then for that you can use column method, and here these are the columns that are there in your data. So days, temperature, winds, events. So these are the columns that I have in my data. So in this way you can get the columns. And let's say you want the data of one column, let's say days column you want. So for that you will write df days, and here you can see all the values of the day column is showing me here. And let's say you want to print a data of days column and temperature, then for that you will use df, and this time we will use 2 square brackets, because when we want values of multiple columns then we have to use 2 square brackets. Then here we will use day, then comma, temperature, and if you'll enter, yes, and here you can see the values of day and temperature. So in this way you can print the values of 2 columns. And here also you can calculate or find out the maximum value of temperature. So I'll use this, and here you can see 35 is the maximum value which is there in temperature column. So in this way you can get the maximum value, or you can also print the value which is, let's say, greater than 32. So for that you will write df, and in bracket I'll use temperature which is greater than 32. So here you can see you have got the value, and here I have printed the complete data where the temperature is greater than 32. Now let's say you want to print that value of day where the temperature is maximum. So let's see our data first. So this is our complete data, and you want to print that value of day where the temperature is maximum. So for that I'll write df in bracket day, and bracket df, again bracket temperature, equals to df temperature dot max. So this is the value where the temperature is maximum. So it's at first index 1 to 2017. So here what I have done, I want the value of day from the complete data where the temperature is maximum. So this is giving me the maximum value of the temperature, and this is taking out the value of day on the behalf of this value. And here you can see the output. So now let's say you want to print the complete data where the temperature is maximum. So for that you will write df temperature equals to df, and in bracket temperature dot max, and this time you have got the complete value where the temperature is maximum. So earlier we got the value of day, and this time we didn't mention that any column name, so we have got the complete value. And you can also calculate the standard deviation. For that I'll use std, and here we got the output. So in this way you can calculate the standard deviation, and there is a method called describe which will calculate the maximum things for you in one go with the help of this describe method. So here you can see it has calculated count, number of values in temperature is 6, mean, so it has calculated the mean, standard deviation, minimum value, 25% of your temperature value, 50%, 75%, and the maximum value, which is 35. Here you can see. So in this way you can use this method, which is very helpful. It will calculate many things in one go for you. Now let's see how we can set the index here. So for that, let's say we have this data, this is the data, and here you can see the indexing is 0 1 2 3 4 5. So instead of this, let's say you want to set day as an index, then for that you will use df dot set index, and in bracket we'll write day. And here you can see this time the indexing is starts from day column. And again, if you'll print df, then so here you can see the difference. This hasn't made the changes in your existing data, because when you are printing your data df, you can see there is no changes, which you have just made the changes here. So your indexing is still showing 0 1 2 3 4. What you will do in that case, I'll write in place equals to true. It will make the changes in my existing data. And if you will print df this time, then here you can see your existing data is updated. So your indexing is the dates that you wanted to set. So in this way you can make the changes in your existing data. You can also check the index values of your data. For that you will use index method, and these are the index values of your data. Now let's say you want to print the values of this index, values of temperature, wind speed, event, which is at this index. Then for that you will write df dot log, and in bracket I'll paste this value, and here you can see. So at this index my values are temperature is 28, wind speed is 2, and event is snow. So you can use log method also to print the values of your data. And let's say you want to reset the index, then for that you will use df dot reset underscore index, and in bracket I'll write in place equals to true, so that it make the changes in my existing data, it update my existing data. And if you'll type df, then here you can see your df data is updated. So in this way you can reset the index. So this was all about how we can create a data frame in Pandas. Now let's see how we can read and write the CSV file or Excel file in Pandas. As you know, to read any CSV file we will use df equals to pd dot read CSV, and in bracket I'll write the file name. So let's say stock data dot CSV, and if you'll print df, then here you can see, so there is another file that I've saved on the same location. This time it's stock data, and here I have read this stock file in my program. So in this way you can read any CSV file that we have just covered. So there is a method called Skiprows. Let's say you want to skip one row, so Skiprows is 1, and if you'll print df, then here you can see it has skipped the first row. And there is one more method called header. So let's say instead of skip rows, if you are using header, and let's say the value is 3, and if you'll print df, then this time you can see it has skipped 2 rows and it starts from the third row. So this is the difference between skip rows and header. So here you are giving 3, so it will work till 2, and in skip rows you are giving 1, so it is working only for the first row, means it is skipping the first row. So in both the cases it is skipping the rows, but there is a difference. Now let's say you want to add new headers to your data. Then for that, first I'll read the file again, and then I'll enter the headers name. So these are the names that I want to add, and bracket close, and you will print df. Then here you can see these are your new headers, and earlier these were your headers. So in this way you can add the headers in your data. And there is a method nrows that you can use to print number of rows along with the header. So nrows equals to, let's say, 2, and if you will print df, so along with the headers it will print the number of rows. Now let's say in your data there are some missing values that you can see. Here you don't have any value, and here you have not available. So let's say you want to replace all such values with none. Then for that, again I'll read the data first, and then I'll replace the value with none. So where there is na and where there is not available, these values will be replaced with nan. So if you'll print, then here you can see your value is replaced. So all the values where there is na and not available is replaced with nan. So in this way you can replace the value. So first I have read the file, and then to replace the values I have used na values, and I have entered the values which I want to replace. So na and not available are the values that I have replaced here with nan. So in this way you can replace the values, and you can also replace the values in this way. Again here I have read the data first, and then to replace the values with nan, and these are the values which I have replaced. So this time I have used dictionary here. So EPS, revenue and people are the keys, and these are the values. And in EPS column, if there is not available, then it will be replaced with nan, and in revenue column if there is -1, then it will be replaced with nan, and in people column if there is not available and any value, then that too will be replaced with nan. So if you will print df, so here you can see this time I have specified the column name where I want to replace the values with nan. So in this way you can replace the values with nan in any specific column. Now let's see how we can create a CSV file of the data that we have here in df variable. So df is the variable and this is the data which is saved in df variable. So now I want to create a new CSV file and we'll save it on the same path where this file is saved. So to create CSV file, I'll use df dot to CSV and in bracket I'll use new dot CSV and comma index equals to false. So why I'm using index here, I'll show you. So this is the data that I'm going to save in CSV format. So you can see this is the file which I have just created. This is the CSV file and this is the data that I have saved. So index false means now you can see there is no indexing 0 1 2 3 4. So this is the reason why I have used index false. So if I'll not use here this index false, and if I'll open that file, then here you can see it is giving me an indexing. So if you will not use index equals to false, then it will give you an index which I think is not required in Excel format because we already have the index here, so there is no need of it. So that's why I have used index false. So here let's use index equals to false, and we can also use header equals to false. So if I'm using header equals to false, what will happen? Here you can see this is the header and here I have used header false. Then in CSV file this header will be removed and this is the only data that I'll have. So I'll show you. So if you see this file, here you can see that header is not there. So in this way you can use header method also. And let's say you want to create a data of only this thicker column and let's say this people columns, then for that you can use columns equals to, in bracket you can use tickers comma let's say people. So these are the two columns that you want to use in your file, and if you'll run the program, there should be a comma. So if you'll run the program and if you see the file, this is the file and here you can see your data is updated. You have only two columns. So in this way also you can create a file. So now let's see how we can handle the missing data in Pandas. So let's say I have this data, weather data, and I'm reading this file here, and if you'll print df, then this is the data which is saved in CSV format on the same location. So here I have used a parse date just to change the format of the date. If you'll not use it, then let me show you what will happen. So here you can see the date format. It is in this way. You can see the slashes between month and dates. So this is the only reason why I have used parse date here. It will just change the format of the dates that you can see here. And now you can see there are some NN values in my data which I want to fill. So first I'll set the index day as an index. So for that I'll use df dot set index and in bracket I'll pass day column in place equals to true. And if you will print df, then here you can see we have set the day as an index. So this we have already seen. Now we will handle the NN values. Let's say I want to fill these NN values with 0, then for that I'll use new df equals to df dot fill na. So new df is a new variable. You can take any variable. I have used here new df. So df dot fill na, and I want to replace the NN values with 0, and if you will print new df, then here you can see in the output all the NaN values is being replaced with 0. So in this way you can replace the NaN values, and as I have told you, you can replace it in any specific column. So for that you have to use dictionary. We have already covered that, so I'll show you here. So like in this way you can also replace the values. For that you can write in this way, and if you'll print df, then here you can see the event column, your NaN value is replaced with no event. So in this way you can replace the values. And to fill the values, there is one more method, bfill, that you can use. Let me show you first the data. So this is what we have. So this is the value that we have in df, and here you can see the NaN values. And if you want to fill these NaN values by using bfill, then what will happen? You just simply use new df.fillna, and there is a method that I've just told you, it's bfill. So if I'll use this method, what will happen? So let me print new df, and here we go. This is the data that is stored in df, and here I have used bfill method and print this new df, and here you can see the second value was nan, and I have used bfill. So here the value which is showing below this is copied here. So here we have 28, the same value is copied here. So in the same way you can see this in this index on 6th. So now the value is 32, so it has copied the value which is showing below. So in this way this bfill method is working. So it is basically copying the values which is showing below. So let's say if your last value is a nan value, then in that case it will remain nan because there is no value showing below. This is the last value. So in this way this fill method works. And let's say if you use access also with this method, let's say here you have used, let's say access equals to columns, and if you'll print new df, then this time let me show you the original data first. Print df. So this is the original data, and now I have used this bfill method, and I have used access column as well. So by using this access, then this earlier it was copying the value which is showing below, and this time I have used access column, so it is copying column values. So here you can see instead of copying 7, it has copied snow here. So here also I have two nan values, and in the last I have sunny, so it has copied sunny here and then here. So in this way this b method works with access. So by default the value of access is row, but here I have used column, so it is copying the column values. So in the same way you can use forward fill. Let's say again you have this, but instead of using bfill, this time let's say we use forward fill, and just remove this access. Let's see without using access first. So here we go. So first it has printed the original data, so this is our original data, and then we have used this forward fill method, and earlier it was copying the values which is showing below, and this time it will copy the value which is showing above. So here is the nan. Earlier it was copying this value, but this time it has copied the values which is showing above. So 9 is the value which you can see here. So in the same way rest of the values it has filled. And if you'll use access column here, LUMS columns, and if you'll run the program, and here you can see 28. So instead of copying snow, it has copied this time 28. So in this way this access works with forward fill. Now let's see the original data first. So this is the data, and you want to drop all the NaN values from your data. So for that we will use drop NA method. So let's say this is the variable, and df dot drop NA bracket, and if you'll print new df, then here you can see it has dropped all the NaN data, and you are getting only those values where you don't have NaN. So you can use this drop NA method for such data. So now let's say you have this data, you can see this data, and here you can see there are some dates which are missing here. Let's see, let's say 2 and 3 is missing here, 4 5 6 7 8 9 10 11. So 2 and 3 are the dates which are missing here, and you want to show those dates here in your data. So whatever the dates are missing here, you want to reflect those dates in your data. Then for that you will use this code. So here what I have done, dt is the variable that I have taken, and pd dot date range. So I have given the date range here from 1 to 11. So it will add all the missing dates with NaN values, and then this dt, I'll pass this dt. Again I have taken another variable idx, and pd dot date time index, in that I have passed this dt. It will store all the dates which will come between 1 to 11, and then I'll use df dot reindex, and I'll pass this idx. So here it will reindex all the dates and give you the data. So if you run this code, here you can see 3 dates which were missing are now added in my data with NaN values. So in this way you can add the missing dates in your data. So this was all about pandas, and in the next pandas video we will cover group by, concat, merge, pivot, meld stacks, and many other things. So I hope you like this video. Thank you so much for giving your time. Have a good day.